So welcome to online session number 31 on molding processes. For example, say compression molding process, transfer molding process, blow molding process by S.B. Patil, Assistant Professor in Mechanical Engineering Department of Jayawantrao Sawant College of Engineering, Hadapsar, Pune. So we are discussing the course outcome number 5, that is to differentiate the thermoplastics and thermosettings and explain polymer processing techniques and identify the plastic applications in automotive parts. So unit number 5 that we are discussing is the processing of polymers. So in this, let us see first the compression molding. So you can see that the compression molding is the oldest plastic processing method. Okay, and the compression mold is made up of two halves, that is the two parts, with one each of which will be connected to the platens of the press. Okay, as shown in this figure. So this is, you can say in the figure, it is the machine used for compression molding for thermosetting materials. Okay, so basically this is the pressing machine. Okay, the pressure is applied by the hydraulic cylinder, and or we can say the compressive forces or compressive stresses are applied by this hydraulic cylinder, and the sheet metal or you can say the plastic or polymer material is situated here, and then it is getting compressed, and then we get the output. So and while it is getting compressed, okay, at that time it is getting heated also. So this mold is electrically heated to maintain the required temperature. Okay, so it means the heating plus compression is here in this compression molding process. Okay, so the mold is electrically heated to maintain the required temperature. The material is placed in the mold and it is closed with hydraulic cylinder or using some clamp, toggle clamps. Then the pressure maintained on the material is of the order 14 to 40 MPa of the molding area. Then as the material comes in contact with the heated mold surface, it softens and fills the entire cavity, and at the same time initiates the chemical reaction which cures the part. Okay, and the cure time is determined by the thickest cross section, mold temperature, material type, and the grade of the material. And after curing, the mold opens and the part is ejected. And the most widely used plastic is phenyl formaldehyde, commonly known as the bakelite material. So let us see this in this figure, that the steps in compression molding for thermosetting materials. Okay, so this is the punch, or you can say the upper mold half, and this is the lower mold half. The charge is nothing but the input plastic material or polymer or granulates that can be situated here. Okay, then this lower mold half is getting heated so that this will liquidify and takes this entire volume of this cavity, and then the punch is forcefully acted upon that charge. Okay, and then there is a knockout pin. So this use of the knockout pin is to taken out this particular specimen out of this mold. So this is the basic compression molding process, and generally the compression molding process is done on the thermosetting materials. Again the same figure, that there is upper mold half, lower mold half, the charge which is getting heated here, and then punch downwards to get this particular shape. So while punch, when punch is moving downward, so there is a V and F. F means the force. Okay, F means the force, that is compressive force, and V is nothing but the speed of the punch. Okay, and after getting complete reaction or after getting the completion of the product, it is taken out by this knockout pin. So basic steps are there, that charge is loaded, and second and third, that charge is compressed and cured. Okay, and then part is ejected and removed. So let us see the video regarding this compression molding. Before that, we'll see that material for compression molding are phenolics material, melamine material, urea formaldehyde, epoxies, urethanes, and elastomers. So generally for compression molding, the all kinds of thermosetting materials and the elastomers are used for compression molding. Typical moldings include electric plugs, sockets, pot handles, dinnerware plates. So these are some typical applications. The advantages of compression molding in these applications include that molds that are simpler and less expensive, less scrap can be observed, low residual stresses in the molded part. And typical disadvantage is longer cycle time and therefore low production rate than the injection molding. Okay, so we'll see this video regarding the compression molding. So here in the compression molding, there is a heating plus the compression process or compressive stress is applied. Moving to next slide. Next is the transfer molding. So the transfer molding is very similar to the compression molding. Okay, and is developed to avoid some disadvantages found in that process. So in this method, the thermosetting charge is heated and compressed in separate chambers. So this is the only difference between the compression molding and transfer molding. That in the transfer molding, the thermosetting charge, or you can say the input thermosetting plastics, is heated and compressed in a separate chamber and then injected to the closed mold where it is allowed to cool and solidify. Okay, so here two different sections are there. One is the heating section and other is the cooling section. So here in transfer molding, it's capable of molding part shapes that are more intricate than the compression molding, but not as intricate as the injection molding. So if you can see, according to the geometry of the particular output of that plastics, okay, if the geometry is somewhat say complex geometry, then we go for the injection molding. If it is less complex, then we can go for the transfer molding. And if the geometry of that polymer after processing or required geometry or required shapes, you can say, is simpler, then it is a transfer molding or compression molding. So according to the complexity in the shapes that we need, we can mark these molding processes in rank wise. That say that first say compression molding, very uh, less or no complexity, then somewhat complexity in transfer molding, then more complex products can be obtained from the injection molding. Okay. So here in a transfer molding, the thermosetting charge is loaded into transfer pot immediately above the mold cavity. And here the charge is heated and pressure is applied to force the softened polymer to flow into the heated mold where curing takes place. Okay, so we require some kind of force or some kind of pressure to pass the particular softened polymer, okay, or to inject this softened polymer to get it cured or to get it cooled. And the curing time required here again in transfer molding is less than that required in a compression molding. After the curing, the transfer ram is retracted while the molded part is ejected from the mold. Screw and the leftover metal with the ram called cull are scrap and need to be discarded since they cannot be recycled. Okay, so as why it is not getting recycled, because we are dealing here with the thermosetting materials. So let us see here in this figure the steps in a transfer molding for thermosetting materials. So this is the transfer ram, the transfer pot where we put all the charge or preform. Okay, now the name here given here is preform. Preform means this particular charge or this particular say uh, plastic inputs or granules of the plastic are heated and compressed in another section. Okay, and that heated and compressed charge, that is preformed charge, is putting here in this transfer pot. Okay, and then it is getting injected. Okay, when it is getting injected, then it goes to this particular shape. Okay, and then we get this particular type of the molded part, and for that we require this ejector pin. So the role of the ejector pin is to take out the particular molded part. Same figure here, the transfer ram charge, that is preformed charge, that is heated plus compressed uh, plastic material in a transfer pot. Then it is say injected. So when transfer ram is punch, or you can say application of compressive force on this charge, it is getting injected through the shapes. Okay, through this particular shape, and then it is getting taken out after cooling. That and that will become your the molded part. Okay. Now this part here is called as the sprue. That the same that we have seen in the casting also. Okay, this particular part, let me color it. Let me highlight. This is the sprue. Okay, or you can say sprue, or what other name you can give it to this. That this is not a part of the your mold. Okay, so this is a sprue, and when the charge is getting injected, it is getting cooled here also. So you can get such a kind of shapes, that is cull and sprue at the bottom of that transfer ram, and this can be trimmed. This can be trimmed out later. So basically this is a pot transfer molding in which charge is injected from a spot through vertical sprue channel into the cavity. So this is the vertical sprue channel, and this is the cavity. Next is a plunger transfer molding in which charge is injected by means of a plunger from a heated well through lateral channels into the mold cavity. So the basic difference here is the charge injected through this sprue, okay, through this sprue, and here in a plunger it is injected by means of the plunger only. Okay, so it is injected here so that we get this is the cavity. So that particular mold or charge, okay, particular charge goes inside this cavity. Okay, and we'll get this shape. Okay, so basic required shape is this. So this is the basic required shape. Okay, and the unwanted material that can be trimmed is this material. So this is called as a cull, or you can say the unwanted material that can be trimmed in later processes. Okay, so the transfer molding also lends itself to molding with inserts in which metal or ceramic insert placed into the cavity prior to the injection and the heated plastic bonds to the insert during molding. So since the mold is closed before the plastic is injected, the time taken for injection is less. Okay, and it is possible to have longer core pins since they can be supported at both ends. The maintenance is relatively low because of small pressures are involved. Generates waste material in form of cull and sprue. These are the waste material that we have seen. And compared to compression molding, high molding pressures are required for transfer process. So fewer cavities can be put into a press from the same capacity. So let us see the video regarding the transfer molding. Okay, now we'll move to the next session, that is the blow molding and the rotational molding. Okay, so in this session, we'll see the blow molding today and rotational molding in the next session. But we need to see both together as the both the processes are used to make hollow, seamless parts of thermoplastic polymers. Okay, and the rotational molding can also be used for the thermosets. So generally, the blow molding is used for the thermoplastics, and we have seen that compression and transfer molding. Okay, that process is carried out on the thermosetting materials. The parts range in the size of small plastic bottles of only 5 ml, okay, to large storage drums of to 38,000 liters capacity. Although the two processes compete in certain cases, generally they have found their own niches. The blow molding is more suited here to the mass production of small disposable containers, whereas rotational molding favors large and hollow shapes. Okay, so generally blow molding, if you can differentiate between blow and rotational, so blow is generally used for thermoplastic polymers. Rotational can be for both, and you can say that blow molding is for the smaller containers, and to if you want bigger containers, large hollow shapes, plastic materials or processing, then we go for the rotational molding. So let us see blow molding. So blow molding is a process of inflating a hot, hollow thermoplastic preform or partition inside a closed mold so that its shape conforms to that of the mold cavity. So basic process is same that to get it conform the shape of the mold cavity. So must be a mold cavity of the desired shape. Only the way of putting the input material into that mold is different. So here in the blow molding, it is a process of inflating. Okay, it is a process of inflating means there is a uh, you can say a parameter that is the air pressure. Okay, so air pressure is there along with the hot means temperature is there. So air pressure plus temperature is there to get hollow thermoplastic free form. Okay, so that the shape conforms the out that of the mold cavity. So wide variety of hollow parts, including plastic bottles, can be produced from many different thermoplastic materials using this process. So generally, the blow molding process is used for the plastic manufacturing of the plastic bottles. So blow molding is a molding process in which air pressure is used to inflate soft plastic inside a mold cavity. So it is an important industrial process for making one piece hollow plastic parts with thin walls, such as bottles, similar to containers. Because many of these items are used for consumer beverages for mass markets, production is typically organized for very high quantities. Okay, so if you have gone through that interactive video that I given on a Moodle, so that is regarding the blow molding process of or the manufacturing of plastic bottles. So that is nothing but the blow molding process. The cost of blow molded parts is higher than that of the injection molded parts, but lower than the rotational molded. Tooling costs are lower compared to injection molding. Cycle times higher compared to injection molding. Why? Because of the pressure is involved or because of the process. So what is the process? Extra process is here. So extra process is to inflate the soft plastic using the air pressure. So that is the extra process is there. That is why cycle time is somewhat higher. Typical parts are bottles, toys, air ducts for automobiles, chemicals and gasoline tanks, number of household goods. So these are the basic applications of the blow moldings. So let us see the video regarding the blow molding process. Now let us go to the next slide. So here let us see the extrusion blow molding. So I think we have seen this video. The first video we have seen for the blow molding, that is nothing but the extrusion blow molding. So we know that in the extrusion process, the three sections are there. That is the feed section, compression section, and the metering section. Okay. So the same extrusion blow molding process there. Let us see in detail that extrusion blow molding machine consists of an extruder similar to that used with the plastic extrusion, which softens the plastic and forms it into a tube called parison or preform through conventional type die and split body mold as shown figure. Okay, so it is similar that we have seen in a plastic extrusion of plastic processes. Die closes around this parison or you can say a tube or preform, sealing both ends. Then a blow pin is inserted into the parison to inflate it. So this is the additional process with along with the extrusion of plastic. Okay. So along with the extrusion of plastic, it is the extrusion blow molding. So in as there is a word blow molding, so there is an inflation of the air. Okay. And when the air is getting inflated, the air is getting inflated to the or through this blow pin, okay, which is inserted into that preform. Okay, so it means whatever preform is there, which is formed or a tube structure during the extrusion process. Okay, into that through this blow pin, the air is inserted to inflate it. Okay, causing it to expand and confirm the shape of the cavity. Again, the mold is cooled, and once the part has solidified, it opens and part is getting removed. And this extrusion blow molding is a continuous process that is used to mostly manufacture small, thin wall parts, but can produce parts such as large drums also. Okay, so this is say the operating steps in a blow molding operation. Number A, that is hollow parison is formed with the extruder. So here it is parison is hollow parison is formed along with this extruder. Okay, so basically the extrusion process, extrusion of plastic process is carrying out here. Then the mold closes around the parison and blow pin is inserted. Okay, then this mold is getting closed here along this particular input or preform, or you can say the parison, and then from the bottom, let us say the blow pin is there. Okay, the blow pin is inserted, and then through this blow pin, the air is getting inflated. Okay, so once the air is getting inflated into this parison, it takes the shape of this mold. Okay, it takes the shape of this mold, and then the molds are taken out. So we'll get this molded part, and this blow pin is taken also taken out. Okay, so at number B, that is this figure, you can say the mold closes around the parison, blow pin inserted. C, that is air is blown into this parison. So here air is blown, thus expanding it to confirm the contours of the mold, or you can say it takes the shape of the mold, and then mold opens and finished part is removed. So basically, in the extrusion blow molding process, there is a extrusion of plastic. Okay, and then in the extrusion of plastic, there are three sections: feeding section, compression, and metering section. So it goes from feeding section to compressive section, then compression to feeding section. Sorry, from compression to metering section, and then through the metering section, it goes into this mold. Okay, and then it getting closed, then air is inflated into it so that it takes shape of this mold, and then the molded part is taken out. So this extrusion blow molding used for wide variety of container shapes, size, neck openings. Machines are very fast, can produce 300 to 350 bottles per hour. The blow molds are generally much less expensive than injection blow molds and produce in a much shorter period of time. Can use many different plastics, like PVC, PC, PP plastics. Capital investment is low and suitable for small production. Some disadvantage that high scrap rate, limited control over wall thickness, and difficulty trimming away that is excess plastic. So let us see the video for the extrusion blow molding. Okay, and this extrusion blow molding is similar to that we have seen the first video in the blow molding. So here single screw extruder. Okay, and through that feeding section, then compression section, and then metering section. So through that metering sections, it is passed to the this mold. Okay, and then the air is inflated into it so that the plastic material takes the shape of the mold cavity. Same you can see the extrusion here, the extrusion takes place. This is the output of the extrusion of plastic, and then mold cavity, and then through this air is getting inflated. So you can see here the air is inflated in this from this section, which is shown here it behind, and it takes the shape of this mold cavity. So first plastic in the accumulator should be the first plastic out. So output of the extrusion of plastic is input to the say blow molding, and therefore it is a term that is the extrusion blow molding process. Moving to next slide, that is the injection blow molding process. So let us say here the operating steps in injection blow molding. So instead of this extrusion of plastic extrusion unit, there is a injection unit. This is the only replacement, and other blow molding process is same. Okay, so if you forget this injection unit here, so other blow molding process is same, that output of this injection or extrusion molding is taken here. Okay, then air is getting inflated so that it takes the shape of the mold, and then mold is taken out so that we get the output material. Okay, so this is the basic blow molding process. Only the way of injecting the plastic into this blow molding process is different. In injection molding process, in extrusion blow molding process, the extrusion of plastics is the, or you can say the output of the extrusion of plastic is input to the blow molding here, and here also the output of the injection unit is the input to the blow molding. So let us see here in detail. Number A, that is hollow partition is formed in the injection mold. here you can see. Then the parison with blowing rod is transferred to the blow mold. Then it is transferred to this blow mold. Then next process are same, that air is blown into the parison, this expanding it to confirm the contours of the mold. The mold opens and finished part is injected. Okay. Only the way of giving the input to the blow molding is different. That's why the name is the injection blow molding, and the unit is uses injection unit. Okay. In the same figure, you can see that inch is getting injected. This plastic material is getting injected into this blow molding process. So while getting injected, it is injected by with some V, that is the speed of this ram, and F, that is compressive forces are applied to this ram. Okay, in this injection unit. Rest process is same, that taking the material, then a blowing of the air, it takes the shape of the mold cavity and will get the output, and the part is getting removed. So the injection blow molding is used to achieve very accurate wall thickness, high quality neck finish, wide mouth openings, and to process polymers that cannot be extruded. Okay, so generally in the extrusion process, what happens, that whatever plastic material we feed through the hopper, it is first getting heated, then it is getting compressed, and then it is metered to next section. Okay, so but sometimes some polymers cannot be compressed in the extrusion process. So for that we need to inject them into the next process. Okay, and that is why for such a polymers that cannot be extruded, we can go for the injection blow molding. So generally injection blow molded containers material is distributed evenly throughout and do not need any trimming or rimming process as we seen in the extrusion process. Okay. Also it's suitable for small containers. Injection blown containers usually have a set gram weight which cannot be changed unless a whole new set of blow stems are built. Okay. So the quantity of the input plastic material is also defined before injection or before injecting into the blow molding process. The usual application include pharmaceutical, cosmetic, single serving liquor bottles that weighs less than 350 gram. So let us see this process, that is injection blow molding process. So let us quickly move to the next session, that is the stretch blow molding. Stretch blow molding, best known for producing the PET bottles, commonly used for water, juice, and variety of other products. It produces parts with required properties for the work material by producing molecular orientation. So in this process, the preform is elongated mechanically in the mold and then expanded radially in the blowing process. Okay, so as the name suggests, that is the stretching. So stretching is done mechanically in the mold to the preform, and then it is passed to blow molding process. Okay, so as a result, the desirable resulting molecular orientation yields a material with increased strength. So why stretching is here required? That if we required a sufficient strength in a particular direction, so in that direction, the preform, or you can say the input plastic material is mechanically elongated. Okay, so that sufficient strength can be achieved in that particular direction of that PET bottle or of that particular material. Okay, and then it expanded to blowing process. So as a result, what happens? It yields a material with increased strength. So strength is going to increase, and this biaxial stretching of material increases the tensile strength, barrier properties, drop impact, clarity, and top load in the container. Okay. So with these increases, it is usually possible to reduce overall weight in the container by 10 to 15% less than when producing a container by simple blow molding techniques. Okay, so it reduces the percentage of 10 to 15 percentage weight, overall weight of that particular material also. So it makes it very handy, or you can say a softer materials. So this blow molding is usually used for difficult blow crystalline and crystallizable polymers such as polypropylene or polyethylene terephthalate, that is the PET bottles. So here you can see that it is a same injection unit blow molding process. Okay, the blow model part, it is getting air is getting blown into this. So let us see the operating steps in stretch blow molding. That hollow parison is formed in the injection mold. Here again same. Then parison with blowing rod is stretched. So this process is added addition process. So whatever parison or whatever preform is injected into this particular blow unit, it is getting stretched, okay, by mechanical means, or you can say that some kind of plastic material is injected into this, and then by some mechanical means it is getting pulled or getting, say, stretched inside the blow molding, and then air is blown, and rest is the blow molding process. Same you can see here that injection unit, the material is getting injected into it, okay, and once it is injected, it is getting stretched by some mechanical means, and then air is passed into it to get the blow molding or to get the blow molded part. Let us quickly see this video. Just a 30 seconds video, that is stretch blow molding. Okay, so same process, that it is plastic material is getting injected, that is the perform of injection. Okay, then it is injected, then it is getting stretched. Okay, it is getting injected, then it is getting stretched, and then air is inflated. So that is the process of production of these, say, bottles. So comparison of the different blow molding techniques: extrusion blow molding, injection blow molding, stretch blow molding. So in extrusion, high production rate, large amount of scrap is there, but low cooling cost and wide selection of equipment. Injection, no scarp, excellent thickness control, accurate neck finish, can produce low volumes. Stretch blow molding, economical, improved, accurate control of wall thickness and reduce the weight allowed. Okay, so quickly, there is a last session. I'm putting this link and event code into the chat box. Just read the today's session by your valuable feedback. Then you can leave the group. So thank you for your feedback and thank you for the today's session. Let me stop the recording.